Okay guys, so yesterday we learned about single covalent bonds. Today you're going to be looking at double and triple bonds. There's really not much more of a difference other than atoms can bond more than once with themselves. With double bonds, they're going to bond twice. With triple bonds, they're going to bond 3 times. So I'm going to show you a couple examples of each, and then you're going to do this practice today on your sheet. Okay, so if we look at our first one, O2, remember it's one of those Hofbrinkel diatomic molecules. And for O2, we're going to draw our O's out in their Lewis dot structures. So remember that each oxygen has 6 valence electrons. Okay, we're going to do that for this one as well. Okay, we have 6 for each. So we're going to take all of our single ladies and we're going to put a ring on them. So instead of having something else come in and work with it, all it does is it just needs to bond to itself twice. So what you're going to end up here, if we draw it out, okay, we have an oxygen going to be double bonded to the other oxygen. And you're going to use your Vesper chart with these to determine the shape, just like you did with the other ones. So if we were doing that, right, this would be our main atom. You can make the other one your main atom too. It doesn't really matter. We have 1 bonded, and we have 2 lone pairs. And what you'll see is that it'll end up making this linear shape that you have here. Another example of a double bond is CO2. So carbon is always usually going to be your central atom because it has 4 different electrons, so it can bond to 4 different things. And so usually everything else goes around it. But if we're looking at this, we have oxygen. Okay, remember oxygen has 6, just like we said up top. And then we're going to do another oxygen. So we're going to do 1, 2, 3, 4, 5, and 6. And so carbon needs 4 more to have a complete set, and each oxygen just needs 2. So you're going to have a double bond here between this carbon and this oxygen, and a double bond here between this carbon and this oxygen. So what you're going to end up with is you're going to end up with another linear sample that's going to look like this, same on each side. So your main atom in this one would be carbon because it has the most stuff bonded to it. There are 2 different elements bonded to that. And then you would go through that lone pair stuff along with that. Okay, so that's double bonds. Triple bonds, it's the same idea except it's bonding 3 times to itself. So if we look at nitrogen as an example, okay, nitrogen has 5 valence electrons. So we're gonna draw that here. Same idea. I usually like to line them up so they can make a nice ring with one another. You don't have to though. Okay, so each of these lone pairs are going to join up with one another, and you're going to end up with a triple bond. Once again, you're going to use that Vesper chart. So we're looking at a main atom. This could be your main atom. It has 1 bonded atom to it and 1 lone pair. And that's going to get you another linear shape. So you're going to do N, you're going to put 3 lines there, and then of course you're going to want to put your valence lone pairs on the outside. One more example of that, we have C2H2. So we have 2 carbons on this one, so your carbons are going to go in the center. And then your hydrogens are going to go outside. You can put them up top, you can put them to the side. I always like to put things to the side first. So we have 1 hydrogen, we have another hydrogen. And so your hydrogens are going to bond with your carbon atoms once, because remember that hydrogens only need 2 valence electrons to be happy. Then your carbon's going to come in and it's going to triple bond with itself here. So you're going to have singular bonds and triple bonds within this one molecule. And what you'll end up with is something that kind of looks like this. It's actually going to be a little different, but you'll see that in time. And if you don't understand how I got the shape here, don't stress about it. We're going to be looking simply. If there's anything on your practice, which I don't think there is, but if there is something on your practice where you're struggling with the shape, don't worry about that part at the moment. I just want you to get how to figure out if it's a double bond, triple bond, or a single bond. All right, so if you have any questions, make sure you write them down. I'll talk about this with you tomorrow, but try your best on the work and we'll see how you do.